Look at this equation showing standard distance calculation. If a runner moves at a rate of 3 kilometers per hour for 5 hours, we multiply the rate by the time. 3 times 5 is 15 kilometers. It is repeated addition, 3 added together 5 times. Watch what happens if we swap out the runner for a tortoise that moves at a slower pace of 1/4 of a kilometer per hour. If it walks for 3 hours, the math rules stay the same. We multiply 3 by 1/4. That gives us 1/4 added 3 times, resulting in a total distance of 3/4 of a kilometer. We can also reverse the variables. If our runner covers 3 kilometers in 1 full hour, let's see how far he goes in 1/5 of an hour. The equation updates to 1/5 times 3. To solve this, we take that whole 3-kilometer block and divide that distance into 5 equal segments, which leaves us with exactly 3/5 of a kilometer. Multiplying a whole number by a fraction scales the whole number by dividing it into equal parts. The core rules of multiplication remain consistent, whether you are using whole numbers or fractions. Those calculations are straightforward because they use at least one whole number. The math requires a new step when we multiply two fractions together. If our tortoise walks 1/4 of a kilometer in a full hour, we need a reliable way to calculate how far it walks in 1/2 of an hour. This diagram shows a 1-by-1 unit square, which we use to visualize a single hole. We represent the tortoise's hourly distance by taking this square, slicing it horizontally into 4 equal rows, and highlighting a single row to map exactly 1/4. To find our answer, we must isolate half of that highlighted 1/4 strip, so we slice it vertically into 2 equal columns. We highlight the single overlapping box where the 1/2 and 1/4 slices intersect. Looking at the entire unit square, you can see the horizontal and vertical slices have divided the whole into 8 equal pieces. Since exactly one piece is shaded by both slices, we know that 1/2 multiplied by 1/4 equals 1/8. The result is smaller than both of our starting numbers. When you multiply two fractions together, you are taking a piece of a whole and slicing it into even smaller pieces. Let's apply this method to a faster tortoise that walks 2/5 of a kilometer per hour. We want to calculate how far it travels in 3/4 of an hour. Here is a fresh unit square. First, we represent our rate by creating 5 horizontal rows and shading 2 of them to establish our 2/5 block. Next, we map the time fraction. We divide the square into 4 vertical columns. Before we shade anything else, count the total number of grid squares created by multiplying 5 rows by 4 columns. Now we shade 3 out of those 4 columns to represent our 3/4 time factor. If you count the matrix, you will see exactly 6 overlapping squares inside a grid of 20 total pieces. That gives us 6/20, which simplifies down to a final answer of 3/10 of a kilometer. Look at this isolated rectangle with a length of 1/2 unit and a breadth of 1/4 unit. To find the geometric area of any rectangle, we multiply length by breadth. We already established that 1/2 times 1/4 equals 1/8. To prove this geometrically, notice that it takes exactly 8 of these smaller fractional rectangles to completely fill a square that holds an area of exactly 1 square unit. The visual fraction grid and the geometric area formula describe the same mathematical reality. Multiplying sides together yields the area, even when those side lengths are fractions. Now it is time to test these visual methods yourself. Here is a challenge straight from your textbook exercises. Try to calculate the product of 2/3 multiplied by 4/5. Grab a piece of paper and draw your own unit square. Figure out your rows and columns, shade in the values, and map out how many overlapping squares you get. Once you find your simplified fraction, drop the final answer in the comments. Let's review the mechanics we mapped out today. This left panel shows how standard multiplication applies to fractions. Multiplying a whole number by a fraction is a process of scaling that fraction through repeated addition. This middle panel shows the visual grid method. When multiplying 2 fractions together, the total number of rows and columns creates your denominator, while the overlapping double-shaded pieces create your numerator. This right panel confirms that multiplying fractional values functions like calculating the area of a rectangle with fractional side lengths. Mastering these grid mechanics provides a visual foundation for how parts of a whole interact. In our next episode, we will see how these rules evolved as we travel back to 628 CE to examine Brahmagupta's contributions and solve the miser's single coin riddle.